Hey, welcome for this session about the O3DE engine. My name is Grzegorz, and I'm the solutions architect and working for the AWS, as actually depicts, right? Um, so, O3DE engine, open source, just a question, a bit of exercise for the very beginning. Yes, no. Have you heard about the O3DE engine before? Yes, yes, yes. Okay. Quite some number, but you guys don't count. I know you. Um, so another question would be, have you heard about the CryEngine? Oh, that's more. Okay. So thank you very much. That was an exercise. So I will maybe surprise you or maybe not. So there was a time when the CryEngine, there was a crisis. The game, very nice. By the way, it was burning our graphic cards back in the day. And the O3D engine is the source, the origin, the DNA of the O3DE is the CryEngine. So essentially, the Crytek has sold it to Amazon, and Amazon took and removed parts of that engine and called it Amazon Lumberyard. So we are back in 2020, and Amazon says, okay, we would like to give this Open3D, this Amazon Lumberyard, in fact, the source code, we cleared it up from proprietary code, and we would like to give it to Linux Foundation. And this is essentially how the Open3D Foundation as well has been established, and the source code of the Lumberyard and former CryEngine with heavy modifications has been released as Open3D engine. This is kind of about the origin of the Open3D engine. So you will see a lot of similarities. So if you ever seen the engine editor from CryEngine, you will see it's quite similar to what you get used to when you see Open3D engine. About the engine itself, why we kind of mention about it, it's because it is high fidelity engine. What does it mean? It means that it can represent graphically very close to real objects, and it is with the precision with PBR, so physical based rendering materials, it can present very true copies of the objects in the world, in the digital world. So it's also modular. So the idea of the Open3D engine, it was that it will be modular. It uses the extensions called gems. The engine entirely is written in C++, spiced by the Python code. And the gems are also developed in C++. So essentially, this is the modules, these gems, can be removed from the engine. So it uses the default Atom renderer, but it's one of the core gems. But if you don't like it, you would like to create your own renderer, feel free, remove it. So what it actually also means that it is open sourced. We release it under the Apache 2.0 license, meaning that there is of course the notice about the license and use, but you are free to modify it, use it for your own purpose, play with the code. And of course it lies on the GitHub on the open public repository that you can download it without any further registration. So just go to O3DE in GitHub, you can just fork it and start working on it. Optionally, if you don't like the Apache 2.0 license, the Open3D Foundation can release it to MIT license, meaning that it's really non-constrained license, just a very basic one. About the engine itself, so it works on both the Windows and Linux. This is where the compilation has been made, but it also compiles from sources on macOS. Because it supports iOS as well. And it's interoperable, meaning that if you export this project, created some project on Windows, you can open it on Linux and vice versa. Regarding the platforms it supports, so as I mentioned before, the engine is written in C++. Inside the editor, you work with the node-based programming, something similar to a Unreal Engine blueprints. Those are called the script canvas. But inside the language, if you don't like script canvas and node-based programming, you can always use the LUA, the Lua editor, and you can use them interchangeably or together within your project. And about the community, so of course this is open source, meaning that this is community supported. So there is community currently. There is a Discord server that you're feel free to join with more than 3,000 active members, and not hiding that it's cloud fidelity. Yeah, there's a cloud guy, AWS, talking about cloud fidelity. But if you think about it, we have the core AWS gem, of course, for this engine. But if you think about the features like metrics and multiplayer hosting, multiplayer games, or networking, it has very robust AZ networking framework. Then of course that makes sense. So it's not like that you have to use the cloud for this; it's optional gem. Continuing, as there are gems, so these extensions, you of course can create your own, but this will be released under Apache 2.0, and of course maintain the licenses. And there are more than 170 gems, which I checked, including the AI, nav meshes, the volumetric clouds, whatever you would need for the 3D engine to build a high fidelity level of the game. So you have no separate contributor license agreement for using these gems. The engine itself is open source, but that might happen that some gems will be licensed. So, but of course, this is mentioned in the description of the gem, which you will see in a second. In terms of platforms it supports, so it compiles on, of course, Linux, Mac, and Windows. There are installers for Windows and Linux. It uses Ubuntu 22.04 LTS. You have the nicely dep package if you would like to use Linux. And you have the Windows installer, of course, for this. It supports consoles, but this is, of course, with a bit of asterisk. You need to obtain the authorization, of course, the binaries. It's C++ engine, so it shouldn't be an issue because these companies like Nintendo, Xbox, PlayStation, they will release you the binaries if you're already a registered developer that you can integrate with an engine and then build, cook, run, of course, the assets for the consoles versions. So full spectrum of devices platforms supported. And now how it compares. I mentioned a few times Unreal Engine, haven't mentioned Unity, haven't mentioned Godot. So how it compares, I know this is a wall of text, this is just an hanger. So what is the most important is that it is really, the O3DE is released under Apache 2.0 and with MIT license if you need it. The architecture-wise, it's different than the big ones, the giants like Unreal and Unity, because it's really modular. So you can get rid of even the core gems, so the core extensions. You can just simply throw away the renderer. You can throw away the asset pipeline. There is even the custom asset pipeline for Python. If you would like to, modify how the assets are imported, you can always take and throw it away and create your own, right? So this is about this modularity. Not so much with Unreal. You can really, I mean, you technically could, but then, see how it will go. So in this case, it's very similar to Godot. With a difference that about the programming language, so it will use the script canvas or this node-based programming inside or the LUA or the Lua. It's a fidelity about this precision, how we can mimic the word. It's kind of comparable with the Unity. And I know the Godot has invested a lot in the 3D since the Unity license announcements, and then backing up from this from this new license agreements. But it's on par with the Unity in terms of the graphical capabilities, and this is thanks to the Atom renderer. The Atom renderer has been rewritten completely for the Open3D engine, so it supports DirectX 12. You can have the Metal 2.0 for Macs, and the Vulkan for Linuxes. It's quite advanced renderer. With this Python script magic, you can actually change how the assets are being processed, because it creates the JSON files. Essentially, a lot of objects within the O3DE engine, post-processing wise, are the JSON. So using Python there to outside of the engine editor, you can of course create your own auxiliary pipeline, how to process things outside the engine. And the most important is that the community, there is more than 3,000 members of the Discord server. And of course, there's GitHub. You can always open an issue and just ping people, Discord them to the dev with issue you're facing. But they are picking up quite fast. I had issues building on Mac. I had reply within 15 minutes on what's happening there. So this is how it kind of assesses. Of course, if we speak about the fidelity, how it can compare to Unreal Engine, Nanite, Lumen, yeah, there's this far off. But where it stands out really, the O3DE engine, is the networking capabilities, because the AZ networking is very lean networking model. So you have this networking baked into the O3DE. And on top of it, you have already an existing multiplayer gem, the node-based scripting. For this, what is nice about the networking there, a bit more about when I will show the demo, is that it uses the clean separation between the networking components such as client and server. So when you build, you can build target immediately to a server, you know which one is server, which one is client, because as I hear from my customers a lot, okay, we create a game, we are trying to add the multiplayer, and there is some codef needed because the netcode is it's very hard to separate the project, what will be a server, what will be a client, how to use these entities. The O3DE has it already built in with the multiplayer and the AZ networking 2.0 framework. And now it's the demo time. Bear with me because it will be a live demo, so you know how live demo goes. If somebody will start, somebody will say it will be the connecting virtually. Good. If somebody will start downloading the Netflix or the cloning this repo, I'll find you. I'm using this official Wi-Fi here. Okay, so I have set up that this is essentially when you first go into the install it or you compile it. And there is the project manager, which you will see. It's okay. You of course you can add a remote project to it by specifying the GitHub repo. It will just show you this little cloud icon, so you can download it. There's of course gems. There is this list, but this is really not interesting unless you're looking for something specific. And of course the engine, you have the setup, the typical setup. When you open editor, when you first create the project, why I'm not creating the project, because there was asset processor that will bleep in a second. This guy. He will start processing assets. So this is all messages, all wordings. But it will start processing the assets. This is why I'm not creating the new project, because it will take on this machine around 1, 3, or 5 minutes to process this initial assets of the engine and import it to the scene. That's why I have prepared one of the empty scenes. Really, this is just a basic gems. I've created this little landscape just to show you that it has the fully featured terrain system. So on top of the gems, they will appear as the components editors, right? So they are like components for your entities. It's using two main objects which you will be playing with are the entities, like this one. Entities live within the level. So when you first create a project, you have to create a level or multiple levels. And those entities are saved with the level. But another object that you can, of course, they are nested. So you can have the childs and other objects within that entity. But the difference is that these are saved with a level, and there are objects called prefabs, and those are really the files on the disk that are saved kind of separately, because if you modify them and you don't save the level, you are kind of losing the changes. If you modify the prefab that is on the disk, you know the drill, right? It's on the file system of your host, or checked into the Perforce, because it has the Perforce native client. Then it lives basically on your file system, and when you can modify it separately, and when you instantiate the object from the prefab, you will of course use that file as a template. Nevertheless, this is really a terrain. If you think I'm not the best level designer, I will agree with you. When you just move around, this is really just a simple plane. What I created there is just a map. There's bump map that is used to create this terrain. There is some lightning already available. I have quite input lag, so I might be, getting you dizzy with, flying here and there. Those are like a basic editor, and it's a basic plane. Nothing serious, really. There are two materials. There is the map and a few tags. What will be a rock material, what will be a terrain material. But this is normally how you create it. There is just an entity called the height map that is bound to an image gradient. But you say, okay, this is nothing spectacular, and I agree. But you can, what you can do, and to quickly prototype or create your levels, you can go into the thing which is called the, bear with me, the landscape canvas. Yeah, find it. So the landscape canvas is this node-based. So the node-based programming is not only for the scripts, for the entities, how you move your actor, how you input your bindings, etc., but it works for both the terrain and the vegetation system. So in fact, if you would like to just spawn a terrain like this, or even better one, or some, so you just create your terrain. It will be a box shape. Added a few elements like the height gradient list. You will of course have the macro material. I'm not the best level designer. You will have the macro material that will be used then for the blending, and then of course maybe the surface gradients and the surface material list that might be the most important one, where you created. It created a quite small terrain with 1.1 meter. I'll enlarge it in a second. But going for the quick configuration, we will just get the surface material list. This is my important guy. Can I scroll down to you? I'm not sure. Okay. Time machine, go away. Let me enlarge it a bit. Yep, somebody's downloading something. Yeah, here we are. So just to build the simple and really quick and dirty landscape using this node-based editor, I will get just rock material. This is standard. This is terrain PBR, which is used the rock. I'll show you that in a second. And now I will just map it to a surface, which is terrain. You create the tags. When you create a material, you create a tag for which is what, to be honest. So I will use, for the terrain, I will use the forest. This is another PBR material, the surface material, and I will add my rock to it, as well as the terrain. Terrain hole will be used here, and I will use my rock again as a surface. And now when I minimize it, normally, it should be a bit better. You will not say, yeah, it's too small. Let me enlarge the terrain scale, because it's created the cube with this terrain 1.1 meter. Now this is not really large. The plane that you've seen there, it's the 256 meters in dimensions in x, y, z. So let me enlarge this one. So we have something like maybe 20 meters. Is it 20? Is it 20? I'm not sure. I'll remove it, yeah. Let's go with 20 meters by, let's say 5. I hope it will. It changed, yeah, I haven't. Okay, and now our surface should be already there. Okay, I think I added the gradient. Let's see. So it will appear, the landscape canvas will appear like this. So let me throw maybe the height gradient so it shows some bumps. It's not a plane. Let me get the, is it random noise? Is it random noise? Okay, so let's see the spikes going. And this really, it's the gradient and how you program in this node selection. You just simply go and drag and drop the node connections. Oh, snap. Trying to figure it out in this, I'll get my neck cramps. Let me get it maybe closer to myself. Okay, did I define the macro material? Yeah, I'll just get the color for the texture material. I'll get some tutorial. This is really just something I'm using for the previous plane. My terrain surface list is it here. All here bound to the tags. Should be this rock, there's terrain, there's gradient. It should be resulting in the nice plane system. We should have here, if I get you. Okay, yeah, this is the live demos glitch. Normally it should, just populate the plane with the material, but maybe we'll get working. On the surface material list, we'll just get its priority to 1. And the layer spawner to 1. Priority, and let's see, you gentlemen, how you will, oh, there we go. So as you can see, it clamped to an edge of my previous plane. So using that plane system, you can essentially just create the mountains, and if you go modify, if you like to create a hole or basically edit or create a large level from multiple planes and surfaces like this, you can of course certainly do it, because they are blending and you are able to influence how these materials are blending and how these terrains are blending between each other. And of course you can influence it from very simply from the canvas. So we have the noise. Another element you can do with it is that you can actually invert it, or you can modify it, or you can posterize. Not really, I'm just not seeing what I'm clicking, sorry for that. But you can okay, let's invert it. So using this node-based landscape, it's not only used, let me delete these. You can not only create, of course, the landscapes and join them together to create a landscape, but you can also create them for the vegetation system, as you can see here, which I'll show you in a second. And of course, these gradients, if you go, and this is really simple, you just inbound gradient, if it connects. You just have that random noise, and of course you have selections like what you will do with the random noise, generate the random seed, and it will invert it essentially. And then of course with the modifiers, you can dynamically, using this canvas, you can create the entire lens system for the level. But this is not the only feature of this landscape canvas if you don't like, to create a plane. So we have the plane now because I removed the gradient. But about the vegetation system, so I'll just move it, I'll hide it. And let's see if I can create a quick vegetation system. But before I do it, I will need to get my assets, meaning currently this is just a plane, right? So to show you that the asset processor is actually working, it's not a phony of some sort. I have my desktop and my wife has created a very nice sofa exported from the Sketchfab, which I will just use to copy. This is the FBX, the standard object. So I'll just copy it, and you have the asset processor is listening for and is scanning the assets and other directories within your project. So if you place it, you will see that there is a pending job, and it's already assessing my nice sofa level. Why it's doing this asset processing, by the way, is because you need to prepare from the source material. You need to prepare something that can be streamed by the graphic card, and my sofa is built. So this is really just, let me place it. So that this would be something like if you work in SketchUp or in architectural producing, you can just import the files from the SketchUp. But now what I really wanted to take is these plans. Let me rotate a bit. You can always center on the material, on the object that you're processing. I just want to grab the plants and use it later for the vegetation system. Not really. If you get dizzy, tell me. Okay, let me see. I think it's there. Okay, got it. So what we can of course do is to create this prefab, which I was talking about. From this material, of course, this is my architectural document. It doesn't preserve the material information, but what can I do with it? I can create this prefab, which will be the object that is created on the file. I will just use the typical name, and it will be a JSON document that is saved with the properties of it. So I don't need my sofa, so I'll clean it up a bit. Is it this one? No, this is the sofa. Yeah, the architectural elements, they usually have a lot of when you import it, they are not cleaned a bit. Okay, but as I have a prefab, I can just go to a landscape canvas again, and I can show you the great vegetation system that is also quite dynamic. So first I need to have the shape that the 3D shape. This is important. The 3D shape that will be taken by the area where these plants or this vegetation system will be operating. So I need to find something like whatever it is. I can see it's the capsule. Capsule should be fine. It's a 3D shape. So I'll get the height to 1 meter, radius, so it's quite big, a bit bigger than this. Let's save it to 10. So now, using this node-based programming, I will just drop it, and I will get the vegetation layer spawner. And so the vegetation, it's using the prefab. That's why I had to create the prefab before. So I'll use it. This was like mesh something as my foreground. And now if I just get to my editor again, the main view should disappear, kindly, please. I'll find what has been just dynamically created. It should be centered to my, and I see already that there are a lot of these plants essentially within my spherical plant set. quite in normal order, but you can see already that it detects the plane and the curve of that plane, and it knows where to plant them. It's just this prefab, this object has been created in such a way that it was hovering above the ground, and how it was basically instantiated from that prefab. I can plant it to the ground a bit. But if you move it, of course, it recognizes the slope and it knows where to place them. They look quite awkward now because they are in a really ordinary shape. So if somebody would see a level like this, it would be looking really terrible because they are like not random, they are like planted in a rows, right? So we can do something about it. And with that, you have, of course, the free ability to modify it. So not only filter it, but you can also get the position modifier and the rotation modifier. So let me add that. Let me get the position modifier as well. We have rotation. I would like to rotate them around the axis Z. And I'll, of course, use the gradient for this and get my random noise will come handy. So instead of just having planted my plants in one row, I can just take a random noise and I can just rotate them around the axis Z in the semi-random order, and it should already look better in terms of being, you know, distributed dynamically. And of course that if I have the normal prefab that is planted on the ground, not in the thin air, I could probably have the better looking system, but I will change that. So I don't like this prefab that was used for this entity. Again, this is saved with level, so I can just simply modify it to something a bit better. So I prepared the one which was called the plant one FBX that was shamelessly stolen from the Sketchfab and downloaded and imported into the engine. So now I should have a better looking vegetation in my editor. Somebody's downloading something? Yep, had the luck. Okay, this looks quite better. You will see that it has, maybe let's zoom it in. Not too much zoom. That it has indeed a random rotation, but it's still distributed evenly across that shape. So my plant is quite nice, but yeah, it's randomly, you know, twisted around the axis Z. But I would like to fix it a bit, so I will use that modifiers, and of course I can use the same gradient to use the position modifier for the X and Y axis, so it should produce me a more realistic look of that planted shapes. A bit better. I wouldn't say it's true, but you can of course modify the gradient and the noise about the noise. And my dynamic vegetation system is actually adjusting to my plane where I planted. It will just randomly spawn my vegetation system. So the same situation would work with the lens as it would work with the vegetation system. The reflections are real. And now about the materials, because this is something I mentioned about the PBR. These rocks are looking a bit shiny. So I have my material editor that I wanted to show you. Still within everything within the engine editor. This rock really looks shiny. Where I have my rock material. This is not it. Sorry, I have a lot of other assets there. There should be more rock material. If once it opens, I'll just get the reflection scale and I'll just do it like less reflective because it's really shiny. And just wanted to show you that you can modify, of course, that is not fully PBR. I haven't filled all the masks there, but just looking for the reflection. You can, of course, modify it like how we zoom in, zoom out on that on the material, so it looks more natural. This is done by the tile U and V, so you can zoom in, zoom out to the high resolution material file. So it is roughness texture easy, and it should be there. Okay, so with this view, I just can't really find it. There should be a the reflection ratio that you can actually drop down, so the material is not that reflective. But looking at the time we have still, I would like to move a bit to a networking, because there is so this is material editor. Essentially, you can edit materials that will be then processed and added to the textures and to the objects that will be spawned in the world. It's quite dynamic, so when you modify the material, it immediately takes happen and it's reflected in the rendering. So it really works. If you just press the camera, I have some shader ball, and which essentially just falls down on the plane. But now moving a bit to networking, so let me close down this one. And yeah, you're really seeing there is the DirectX 12, there's RHI, this is the hardware interface, the rendering hardware interface API using the DirectX 12. But let me move to a multiplayer sample, because this one is really interesting. So it was built on top of the AZ networking 2.0 and the multiplier component, so I can show you really the script in Canvas, how this node-based programming with the spawned network entities worked. When I was mentioning the asset processor working, it's really working. And it takes its time. We can pick around what it is doing. And it runs in parallel, by the way, so it opens like multiple processing jobs. Okay, it finished before I open it. Okay, so I'll go with the new Starbase. Here, this is one of the levels. Of course, this one I have to close. Well, it's loading, really. It hasn't crashed yet. It's just a level, and I'm connecting remotely. So what is using under the hood is actually this network. Why again? Okay, here we go again. So this is the networking. This is one of the examples. We can hide the helpers there, and this is already looking like a level. So this multiple sample is of course also open sourced, and it's placed in the GitHub repository. When you try to play it, let's see how it works in this internet and being a remote desktop, but it's already pre-built. I pre-built it. It using all the networking spawners, and what is nice that you have already the troubleshooting and the debugging GUI built into the gem that I will show you in a second. So we'll see the entities, how much for the network troubleshooting when you're planning the multiplayer game. Quite important when you're planning to host it somewhere. It's like what is being sent and received by the server and the debugging on the desynchronization in between these client and server. Okay, so I'm playing in editor. There are 3 FPS. I know it's warping a bit, but there are 3 FPS sent. So in editor, having the 30 FPS is quite decent. But what is fine for this troubleshooting, which I wanted to show you, that is really working as the server and the client, is this. When you press the home button, essentially there is the already built in the IM GUI for the multiplayer, so you can essentially go, if it allows me. Somebody is downloading anything. Okay. So I'll just show the multiplayer entity stats. And you see already how much each of the objects is consuming. So just going back to our editor in the view. Let me close it. So now you see how much of everything is being consumed and how much data is being transferred over the network when you're troubleshooting and optimizing, actually, so your game is not, floating. It uses very lean networking framework, so it's quite efficient on the network and designed for building those really efficient client server with iterative server architectures. So of course the server was running on the local host, so it wasn't like hosted anywhere. But we have the AWS gem, of course, and if you would like to integrate it with the cloud or any other hosting, you can essentially host it somewhere else. Now going back to my presentation, because that would be kind of concluding the demo. This sample, of course, is free, so you're free to build it and play with it on your own. Let me just go through it, because there's one interesting thing which is happening, is that tomorrow, actually there is a tomorrow, or on 9th, sorry, on Monday there is new release of the O3DE engine. The release cycle is twice a year. There is a version released, and one is happening on the 9th, which brings the very interesting gem and other integrations called robot operating system. So it's not only for the games, but it's also for robotic simulations, for manufacturing simulations, lines and whatnot, and it integrates with this framework, because this operating system is actually a framework. So having this, I can just take the questions if you like to have them. Okay. Then, if you'd like to connect, of course, you can just ping me on Discord or in. Yeah, you have a question.
How much the scripting canvas has been reworked to the compared to the old flow graph system the CryEngine had?
It's completely new system, to be honest. So it was removed completely when it was translated from the CryEngine to the Amazon Lumberyard. And then when the O3DE engine was released, it was completely rewritten from the scratch. So the script canvas is actually completely different than the original CryEngine.
Thanks.
I saw you use the FBX format. Do you support GLTF too?
Yeah, so the asset importer supports the GLTF, as there was kind of in the description. Under the hood, the asset processor is using the Open Asset Import library, and it supports GLTF. It supports the DEA format as well, but with the so-called custom asset importer, the Python asset importer, you can create you can utilize the power of the open asset library that supports wide variants of other formats. You can script your own asset pipeline in Python, so you can support even the formats that are not natively out of the box supported by the O3DE engine. For example, if you like, I don't know, CAD files, you would like to use them, you probably can write your own Python script and import it. What is important, that it processes it to a level that, the output of that Now there is an entire tutorial on this, how to do it. The output of that the script pipeline is compatible with the O3DE and Atom Render in this case. So if there are no more questions, thank you very much for attendance. And yeah, if you would like to talk about O3DE engine or test it around, just do let me know, or just go to GitHub and fetch it your own. Thank you.